Hey everybody, it's Sam. Today we're going to be talking about point-in-time recovery for Postgres. This means that if something happens where the intern deletes the production database, you can just say, let's see where the data was at 10 minutes ago and get going again with your application, and no one has to worry about it at all. So I'm going to dive right in and show you a little example of how it works. All right, let's go. Okay, so let's imagine we made this nice little application here where when we press this button, new records are created, and when we press this big dangerous button, it deletes all of our records. It's a great design, but for our purposes, it shows what we want. So now we're panicking. We deleted everything, but we don't really need to panic because we can just go do a point-in-time recovery. So let's grab this date here, and let's run this script, point-in-time recovery, which has the time. We're going to add the time zone here, which I'll explain later. But so we deleted everything at this exact moment. So let's just go back maybe a minute, and that should give us all of our data back. So what does this script do? Well, this script basically stops Postgres, runs our recovery script on inside of one of the Postgres containers, and then reboots Postgres with the recovery settings all set up. I'm going to go through each one of these steps with you and explain how it works. But let's just see the end result first and then work our way back from there. So all it's doing now is downloading the data from S3. So what it does is has a base backup that we use to generate the secondary from before, and then it replays the wall log on top of that base backup. So the base backup serves as sort of the starting point, and then the wall is each individual transaction on top of that. So you're basically replaying history. And then we give it a certain time to stop at. So it stops replaying history at that specific point. And then when we get to that specific point, then we're good to go because that's where we want to stop before the delete happened. And so we can look here and we can see that the database is ready to accept connections. So the recovery is complete. You can see it here. So we can reload this page, and guess what? All of our objects are still there, and we can breathe a sigh of relief. And it still works again, and we can add new data. Just try not to press the huge delete button again. Now, that's great. So, but how does it all work? So let's just check out, I made a little drawing here. As you can see, we have our primary database, as we have had before, and we have the wall, the write-ahead log, as we talked about before with the secondary. And what the write-ahead log does, just as a quick overview again, is it keeps track of every transaction, every write to the database, so that if the database crashes and there's data in memory that hasn't been written to disk, then what Postgres does is it reads from the wall in sequential order, replaying things just as if a user was doing it themselves. So what we want to do is take advantage of this wall to do point-in-time recovery. So if you have the wall, if you have the write-ahead log, and you have archived this, then theoretically, you could go to any point in the database. You don't even have to worry about event sourcing or something like that because Postgres does it all for you. And there's two concepts you really need to know. There's base backups and then there's the wall. The base backup is basically a copy of all the directory, the data directory for Postgres. It's everything all at once. So it's a little bit bigger, it's heavier, and it is needed to bootstrap the process. So you want to start from the base level and then you replay the wall just as if the primary had crashed itself. And then we are able to set a specific time in the Postgres configuration, which I'll show you in a second, and then that means it'll stop the wall at that specific time. And every time a wall is written, or checkpointed, then what Postgres does is it runs an archive command that we're going to write ourselves. And so this archive command gets called with the new wall segment. And then what we're going to do is upload each of these segments to S3 and the base backups as well. And then when we're recovering, it does basically the opposite, where it, instead of pushing out wall segments, it requests the specific wall segments that it needs to replay the history, and it will request those using a restore command, and then we're going to just copy those segments from S3 back to the database, and then it's going to replay them, and we can go to any time that we want. One of the things that you need to remember is that the base backup is big, but also replaying the wall for a really long period of time is going to be very slow. Hypothetically, we could do one base backup at the first time we launched and then just replay the wall from there, but that's going to be a really slow recovery time, especially if you have thousands and thousands, millions of transactions. So what you want to do is take checkpoints or base backups as long as you want, every day, every hour, every week. So you have a new spot to start the wall replay from, so that when you want to use point-in-time recovery, you don't have to replay so much history all at once. So that's a little bit of the overview of how it works. Now let's dive into the details. So as you remember before, we had the secondary setup and inside Kamal. And the way we had it before was, let's look at the deploy configuration here. The way we had it before was we had the secondary setup down here, and this has all this extra secondary data and runs its own command. And then we had this little thing where we were copying, you can see it here, where we're copying the Postgres configuration and all that stuff into the data, and it was a little dirty. So I went ahead and created my own Postgres Docker file, which is easy for you to do as well. With Kamal, if you want to use a custom Docker file, you just need to make sure that it's using the same registry credentials that you have set up for your main web app, and then you can use any private images that you want. So I'm going to show you how this works. I didn't do much other than add some new commands. So I put this inside this configuration directory, Postgres, and then I put all of the commands in this specific directory just to keep things organized here. So let's see, what does our Docker file do now that's a little bit different than before? Well, first it downloads the AWS CLI, which we're going to use to do the archiving. And then it adds our configurations, our HBA configuration, which we had before, so nothing really new there. And then it adds all these commands for recovery and for archiving and making sure everything works. So let's go into the Postgres configuration here and see what's changed. The first thing we need to do is update the archive command. So the archive command is going to be the one that's used when a wall file needs to be archived, sort of in the name there. It's not so super exciting. But what it's going to do is give you these two parameters, F and P. F is the file name, and then P is the path. So, for example, they have this example here that you can see. If you they want to test to make sure to see if the file exists already. If it doesn't exist already, then we copy and add it on top. If it already exists, then we exit. And that's an important thing because you need to make sure that you are using the correct exit codes for Postgres in these commands so that it knows if it wrote it correctly or if it didn't write it correctly. Because if you give a 0, which is a success, even though the wall wasn't written, then you're going to be losing data because it's going to think that the wall has been written and it's going to delete the wall, and then you're not going to be able to recover for it. So now let's check out this archive command. The archive command is pretty simple, but let's go through. It's almost exactly the same as the restore command, just switched. So all we do is use the S3 CLI, AWS CLI, to check to see if the wall file already exists. If it already exists, we just say, that's fine, it already exists, we already wrote it. And if it doesn't exist, we do this or, bash and an or here, and that's going to echo, so it doesn't exist, continuing, just for a little log. And then what we do is we copy the path. The path is the P from before, which is the wall segment on our host, and we upload it to the S3 bucket under this wall sort of file. And so the S3 bucket is a parameter here that we added in the deploy script. You can see here, S3 bucket. You don't have to use an S3 bucket. So it can be anything because these are just files. So I chose to use S3 because I'm comfortable with S3. I made a specific user on S3 just to access this bucket so that all my credentials are isolated. But you could use anything. You could use Cloudflare R2. You could use another file system. You could use anything. I'm just using S3 because it's flexible and I already know how to use it. But you can update these commands to do anything, since this is just a bash command, or it could be any command. It could be a Ruby command if you have all that set up. But right now it's just AWS. So I have this S3 bucket. Just make sure it's locked down because this is your database and this is your files. And if someone has these, then they can read your data. But no one can read this bucket except for this one user that I have. And so I have these this AWS S3 bucket set up, and the secrets, I'm passing in my AWS access key ID, secret access key, and those are, as before with Kamal, those are just added to my .m file, and then they're injected into the Postgres instance. There's a little something that we have to do to make sure that that's updated that I'll show you in a second. But so this is the archive command, and the archive command, we just check to see if the file exists, and if it doesn't exist, then we upload it. It's pretty straightforward, and that's all we need to know about that. So the only other thing is you want to, first of all, turn archive mode on, and then you can change this timeout command. So this means that maybe you want the wall files to be uploaded at a certain interval every time. The docs recommend a minimum of 60 seconds, less than that, and it happens a little bit too much. And what's going to happen is the wall files are, anytime it's switched, they're going to be full. So that's going to give you 16, I think it's 16 megabytes. I'm not sure about that. Don't quote me on that. But every time you do this, it's going to upload a new wall file. So if you do it too often and your traffic isn't enough, then you're sort of wasting space. So you can figure out the best thing to do. Obviously, if it fills up naturally before this time, then it'll be uploaded. Of course, this is just a maximum timeout in case you wanted to upload it all the time, just in case there wasn't so much traffic. But I wouldn't worry about that too much. I just set it to 60. It's defaulted to 0, which means it never automatically does it, which is also a fine setting if you're not too worried about that. As you can see here, which I'll get into a little bit in a second, but just so that you understand, the restore command is the same sort of setup as the archive command. It's going to take a file, it's going to take a path, and it's going to use that to download from S3 and replay. So I'll show you that. I'll show you how that works right now. So this is the restore command. The restore command is, it looks almost exactly the same, nothing crazy here, pretty easy to understand. We're checking to make sure if the file exists, because it will try to get files that don't exist to see where we are, to see what WAL files there are and what WAL files there aren't. So if it doesn't exist, you want to exit with a error code. So I'm just exiting with 1. And if it does exist, you want to continue and download it and put it onto the correct path that Postgres wants you to. So those are pretty straightforward. So let's look again at the Docker file. And so we have these two commands, and then we have a backup command. This backup command, you can put on a cron job. You can put anything that you want it to run. This is the base backup, so you want this to run maybe weekly, maybe daily, sometime, just so that you don't have to replay the WAL so much when you want to recover. And as you can see, I have it here, and it's sort of a, you might think it's a little silly way to do it, but I didn't want to mess with cron, so I just have it running in a loop, and then it sleeps for a day, and then it runs again. So it just does it once a day. You could update this to sleep and do it whenever you want. You could have it run in a cron job. Doesn't really matter. The point of it is here, what it does do is it runs in the same image as our Postgres. So all of these Postgres is installed, everything like that. AWS is installed, AWS CLI is installed. And basically all it does is, this is all in the same directory here, backup command. What we're doing here is using PG-base backup, which is a built-in command for Postgres, which we used before. It connects to Postgres, runs the base backup, compresses it, and then uploads it to S3 again, and then just removes it at the end, because once it's uploaded to S3, we don't need to keep it on the server. And so the only thing really interesting here that you need to know is we pass in the S3 bucket again, because we're keeping in the same spot, and then the host. So since it's running in a separate container, you can't use localhost to run the base backup. You could run it in the same container as the Postgres that's running from the command line, but I want to be able to have this running as a separate accessory in Kamal. So I need to pass it the Postgres host, and that's just the same host as what it is, 10.0.0.3. And all these commands are documented here, but we're just tar gzip and then doing some verbose logging just to watch how it works. And so you can see PG16 backup. We can just check out, we can actually just check out the logs here for this. I can show you a little bit what it looks like. Nothing crazy here, but basically it just runs, it'll upload it to S3, and boom, that's it. And you can see it's 4 megabytes. My database is pretty small. Just for testing purposes, obviously yours might be bigger. And so this is running all times in the background, and this is just a normal base backup of all the data for your Postgres instance. It will overwrite the configuration file and the hba.conf, etc. So you'll need to re-add those in when you reload from this, which I'll show you in a second. So now we have our base backup. I showed you the archive command. So now we're running, Postgres is running, Postgres is archiving. As we can see here, I can show you how it looks with the archiving, because it'll log for you. So basically right here we can see this WAL. So as we saw before, there's a 404 because it doesn't exist yet, which is fine. We want to see that. Doesn't exist continuing, which we echoed before. And we upload this. This is the WAL file. This is what it looks like. And we're updating that to the S3 file, to the S3 bucket, rather. So that's all looking good. So now we have our base backup. We have our archive running. So let's just check out how, let's just keep checking out the Docker file and see what we need when we actually need to recover. So now we have backups running, but we don't know if they work. So that's the most important part of backups. If your backups aren't tested, then they're not really backups. They're just files in the ether, which is not useful at all. So the most important thing is to test them. So I'm going to show you these recover files, this recover file, which is sort of the last piece of the puzzle. And but first I want to show you one thing that you need to know to run these archive commands and restore commands. So let's check out the start. This is the script that we run at the beginning of when we're loading Postgres. So Postgres, Postgres, the default Postgres Docker file Postgres runs as its own user. So that means that if we install, if we add environmental files, environmental variables, they're for the root user, but we really want them to be for the Postgres user as well. So for example, the secret key and the secret access key, we want these inside the for the Postgres user when we're running the AWS commands, of course. So we take these, we put them in this little file called aws init.sh inside this special directory that the Postgres instance, Postgres Docker image, sources files from. So if you have a file in here with this, and you give it the ownership for the Postgres of the Postgres user, then when Postgres starts, it will run this directory, which means that the access key and secret key will be available to the Postgres user. We're just setting up the hba.conf file, and we are doing something a little bit tricky here. This is just sort of a hack to get around some of the problems with running Postgres inside of a container. So Postgres, the data directory is what we are mounting into every time. So let's check out I'll show you the deployment thing here. So we have this Postgres volume, right? Var-lib Postgres data, so that when we restart the container, we don't lose all of our data, which is important and good to have. But also what it means is when things live inside that directory, if we want to like update them each time, or for example, when the base backup is replayed on top of it, the pg hba.conf file gets overwritten, but then it doesn't get written again because the volume is mounted on top and the volume saves the data. So it's sort of confusing and it's sort of annoying, which is why we do some of these sort of hacky things like copying the HBA file into the data directory on load, and then also do this little thing here where we manipulate the Postgres configuration file to insert the point-in-time recovery. So I'm going to show you how the recover script works when we're running a point-in-time recovery, and then this will make sense. So this is what gets called from our recovery point-in-time recovery script, and this is going to be run on a specific on the Kamal PG image, with the Kamal PG image here. So it's in this etc recover. It uses the base backup, which is the base backup we just talked about, which is the sort of the key in S3 for the base backup, and then the point in time recovery, which is the which is sort of the time we want to stop the wall replay. So how does that work? Well, we have the base backup, which is 1, point in time recovery, which is 2, data directory, backup directory, just a few things that we want to have here. So what you have to do is remove the data directory. Now, there's processes and stuff using the data directory, and so sometimes it'll hang, and we can just sort of ignore that. If you do run into problems, there might be something that you need to do there, but this is usually just a problem with some processes looking at it while you're running the container, and it's fine to sort of ignore that. Some people might not think that's fine. There's probably maybe something there that we could do where we're check who's opening the files, stop the processes, and do that. But this actually works okay, so I'm just sort of ignoring that error for now. Then we're going to download the base backup from S3. So the base backup is the tar and gzipped file that we uploaded from that secondary container, the backup base, and we have it under this full backups file structure. And we also, inside the base backup, we also have the wall, so the existing wall directory at the time that we did the base backup, which we also want to have, so that gets replayed in there. And then we just unzip, untar, and ungzip these into their respective directories, the data directory and then the PG wall directory here. And then we do this little hacky thing where we take the timestamp and we put it into this file recovery target, which is then used on start. It checks to see if this file exists. If it does, then we update the configuration file to use that as the recovery target. It's pretty straightforward. The only thing you need to know is that the timestamp needs to be in the Postgres timestamp with time zone format, which looks like this. And then this is just the UTC offset. There's a few other ways you can pass this data in, and I encourage you to check out the docs to show you exactly how that works. So we just save this in here. We echo it just to show. And then the last thing that we need to do is signal to Postgres that we are in a recovery. So the thing that we need to do is add this recovery.signal file. And that's all. So the last thing we want to do is look at the configuration again, the Postgres configuration, and look at the recovery target action. Now, recovery target action means what happens when we get to the end of the recovery. Now, I have it set as promote, which means that it'll automatically open itself up to writes. The default is pause. Now, pause will pause the directory, the Postgres instance itself, allowing only read only. So basically, it allows you to run some SQL queries against it to make sure that everything is fine. And then you run a command called, I think, wall resume or something like that, which will then allow writes to happen again. And so pause is probably the sort of more conservative, maybe more practical default to have, but for now, I like promote. If you do pause, though, you just need to remember that you need to run that command, but then also you're going to want to delete that recovery.signal file so that it doesn't think it's still in recovery mode if it shuts down and starts again. If you use promote, for example, it automatically deletes that file, so you don't need to worry about it. And then shutdown is maybe unsurprisingly, it shuts down the instance when you're done. So all in all, what you have now is a system that will allow you to recover from any problem that you could ever have with Postgres at a specific point in time And that makes it so that you can feel safe. And also, another really great sort of boon that you get from this is that you can now create a secondary, create a certain time from that recovery time for that secondary, and have it have you be able to look at the database at a specific time and place, which gives you the ability to sort of see data that's changed. Maybe you need to copy over something that got deleted by accident. You don't want to redo the whole database itself. So you can pull up a secondary, replay to that specific point in time, and then you are ready to go. So that's all you need to run a point-in-time recovery setup for Postgres. We have the base backups, we have the wall, and now you can feel comfortable that your Postgres instance is safe and you have backups that are going to help you in any disaster. If you enjoyed this video, please subscribe, and I'll see you again next week.